Hi everyone, hope you are all fine. So today we will be discussing on the method of images. Firstly, I will start from the previous lecture, that is what is the potential. We know that potential is the transformation from a vector field to a scalar field to make life easier. Okay, so now my first question, what is the dimension of potential? Okay, let me find it out. It's very easy because we know electric field is equal to minus grad of V. So what is the dimension of E? If you multiply it with Q in both sides, then this is force of dimension M L T to the power minus 2. And what is the dimension of Q? Equals to I T. And what is the dimension of del or grad? That is del x. That means L minus 2 and V. So these both are same. So V equals to M L L minus 1 minus 2. Oh, sorry. L2 and T to the power minus 3 I minus 1. This is the dimension of potential. Okay. Now our main topic, method of images. Okay, let me start such a way that you will figure it out very easily. Suppose we have a charge at point P, charge is Q, and from that distance D or 2D, whatever, minus Q charge is here. So what will be the potential at the midpoint? That is D on the both charges, Q and minus Q. This is, we know that potential will also follow superposition principle. So V at, suppose this is x equals to 0. So V x equals to 0 will be Q by 4 pi epsilon naught D minus Q by 4 pi epsilon naught D. So this is 0. So at that point the potential is 0. Now if we go with this virtual plane, suppose this is an x-axis, now we are considering the entire yz plane, everywhere the potential will be 0. You can check it out. This is your assignment number 1. Okay, so potential along yz plane will be 0. So we can think that this plane, as potential is always 0, this plane is nothing but grounded. So this plane is virtually grounded. There is actually no plane, metallic or the conducting plane, but we can think a virtual plane which is virtually grounded. In a inverse problem, we can think of that there is really a plane, a conducting plane which is really grounded. Now what will happen if we don't consider any charge over here? So virtual plane along yz plane, conducting plane, so it is grounded, so potential will always be 0. Now to keep the virtually grounded plane, there will always be need of another charge in the, as like previous problem, minus Q. So the problem remains the same. Okay, but this charge is not actual charge, this is a virtual charge. Earlier it was virtual plane, now it is virtual charge. That is the difference. So this is called a image problem. Here the charge just opposite, and mirror inversion is also there, negative charge. So this and distance will also be the same. So this is exactly mirror problem as we have studied in optics. Now, think in a different way. Suppose we have this is z plane. Okay. Now we are considering xy plane as virtually grounded. Okay. Is 0. Now we are thinking the charge of q at distance d and minus q at distance d also, and at an arbitrary point x, y, z. Now what will be the potential at that point P, for example? It's very easy. V equals to at x, y and z, that is q by 4 pi epsilon naught 1 by x square plus y square plus z minus d whole square whole to the power half minus q by 4 pi epsilon naught 1 by x square plus y square plus z plus d whole square whole to the power half. So suppose we are considering only along z axis, that is x and y both are 0 and z is far away from this point. So for that case x 0, y 0, then the result will be 1 by z minus d minus 1 by z plus d. Finally it will be 2 q d by 4 pi epsilon naught z square. This is nothing but the potential due to a dipole. So this is a dipole problem. Okay, we will be discussing dipole multipole expansion in the next lectures. Okay, so this is so far so good. This is the concept of, still it is continuing as an image problem. Now we will give a real life example and then we will give some assignment. Suppose there is a conducting sphere virtually grounded, conducting sphere. So the sphere, the surface potential will always be 0. Now this is the origin and a charge is situated at point, suppose this is origin, this is the radius r, this is the distance d. So this is plus q charge. Now what will be the amount? What will be the amount of image charge and in which position we have to determine. Suppose from the symmetric point of view, this is spherical and this is along axis, so point charge should always be remained at some in the same axis. So suppose we have another point, this is suppose A. So this is D and this is A point. A. Okay. So we have boundary conditions. Boundary conditions what? At this point potential will be 0. When another reference point V equals 0 at that point. Okay. Now suppose we have the charge here is Q. Okay. So distance is A. We have to determine the value of A and the value of Q. Okay. We can think of this distance A. Okay, fine. Okay. So potential here due to this at point P1, here it is point P2. Potential at B, P1, that is Q by 4 pi epsilon naught. What is the distance? D. D, simple D, and due to this charge plus Q by 4 pi epsilon naught what is the distance? R minus A. Okay, R minus A. Equation number 1. This is 0. Equation number 2. Here, what is the potential due to this charge? Vp2 Q by 4 pi epsilon naught. This is D plus 2R. Okay, and then plus Q 4 pi epsilon naught. What is this distance? 2R minus or R plus A. R plus A. This is also 0. So if you solve these two equations, you can easily find that what is the value of Q and D. Oh, sorry, Q and A, capital Q and A. This is just Q will be minus R Q by A, and this is assignment. You have to calculate these two equations, and this A will be R square, sorry, square D by T. So this is the solution. Just the negative sign will be there, opposite. So just solve these two linear equations and you will easily find the value. If you think any problem, just use the comment section for better clarification. I'll give another video or I'll give some short note, and I'll definitely give a series of assignments considering the previous lecture as well as this lecture. Okay, so thank you. We'll be meeting in the next episode.